Hello everyone, welcome to the channel. So today we'll be studying parameters of the four terminal network or two port network. So there are three parameters. The first one is the Z parameter or the open circuit impedance parameter. The second one is the Y parameter or the short circuit admittance parameter. And the third one is the H parameter or the hybrid parameter. Now, what parameter basically means is that it is a physical quantity on input and output terminal which explains the behavior of the terminal. Now, the first one is the Z parameter. It is also known as the open circuit impedance parameter. Now, let us imagine a four terminal network. Flow of current in input terminal is I1 and the voltage is V1. The flow of current in output terminal is I2 and the voltage is V2. 1 are the input port and 2 are the output port. Therefore, the name two-port network. Now, parameter in which input current I1 and output current I2 exist in free variable form are known as Z parameter. What that means is that V1 is equals to function of I1 comma I2 and V2 is equals to function of I1 comma I2. Here I1 and I2 are in the free variable form. On total differentiation of first, we get equation second. Now let the change in current is I and the change in voltage is V. Then we get V1 is equals to ZI I1 plus ZR I2 and V2 is equals to ZF I1 plus Z0 I2. Here ZI, ZR, ZF and Z0 are the Z parameters. When output terminal is open or I2 is equals to 0, Zi is equals to Z11 is equals to V1 by I1. Here Z11 is the Zi represented in the matrix form. Zi is known as the input driving point impedance. And Zf is equals to Z21 is equals to V2 by I1 and is known as the forward transfer impedance. Z21 is the Zf represented in the matrix form. Now, when the input terminal or input port is open or I1 is equals to 0, Zr is equals to Z12 is equals to V1 by I2 and it's known as the reverse transfer impedance. And Z0 is equals to Z22 is equals to V2 by I2 and it is known as the output driving point impedance. Now, when we replace Zi, Zr, Zf and Z0 with Z11, Z12, Z21 and Z22, we get equation 4 and equation 4 is known as the parameter equation of Z parameter. In the matrix form, it is represented as here Z11, Z12, Z21 and Z22 are called the Z parameter. Now the second one is the Y parameter. It is also known as the short circuit admittance parameter. Now let the flow of current in input terminal is I1 and the voltage is V1 and the flow of current in output terminal is I2 and the voltage is V2, then parameter in which input voltage V1 and output voltage V2 exist in free variable form is known as the Y parameter. That is, I1 is equals to function of V1 comma V2 and I2 is equals to function of V1 comma V2. On total differentiation of first, we get equation second. Now let the change in current is I and the change in voltage is V. And from the definition of the admittance, that is Y is equals to I by V, we get I1 is equals to yi v1 plus yr v2 and I2 is equals to yf v1 plus y naught v2. Here yi, yr, yf and y naught are the y parameters. Now when the output terminal or the output port is short circuited, that is V2 is equals to 0, Yi is equals to Y11 is equals to I1 by V1. Yi is known as the input driving point admittance and Yf is equals to Y21 is equals to I2 by V1 and it is known as the forward transfer admittance. When input port is short circuited or V1 is equals to 0, Yr is equals to Y12 is equals to I1 by V2 and it is known as the reverse transfer admittance and Y0 is equals to I2 by V2 and it is known as the output driving point admittance. Now we will replace Yi, Yr, Yf and Y0 by Y11, Y12, Y21 and Y22. We get equation 4 and it is known as the parameter equation of Y parameter. In matrix form it is represented as here y11, y12, y21 and y22 are called the y parameter. Now the third one is the h parameter. So let us imagine a four terminal network. The flow of current in input terminal is I1 and the voltage is V1 and the output terminal current is I2 and the voltage is V2. Now the parameter in which input current I1 and output voltage V2 exists in free variable form is known as the h parameter. That is, V1 is equals to function of I1 comma V2 and I2 is equals to function of I1 comma V2. Here I1 and V2 are in the free variable form. On total differentiation of first, we get equation 2. Now that the change in current is equals to I and the change in voltage is V, then from equation 2 we get equation 3 as V1 is equals to HI I1 plus HR V2 and I2 is equals to HF I1 plus H naught V2. Here HI, HR, HF and H naught are the H parameters. When output port is short circuited, that is V2 is equals to 0, HI is equals to V1 by I1 and is known as the input impedance and HF is equals to I2 by I1 and is known as the forward current gain. When input port is open, that is I1 is equals to 0, HR is equals to V1 by V2 and is known as the reverse voltage gain and H0 is equals to I2 by V2 and is known as the output admittance. When we replace HI, HR, HF and H0 by H11, H12, H21 and H22, we get equation 4 as V1 is equals to H11 I1 plus H12 V2 and I2 is equals to H21 I1 plus H22 V2. Equation 4 is known as the H parameter equation. In the matrix form, here H11, H12, H21 and H22 are the H parameter. Thank you.